Good day, everyone. In this video, we are going to tackle the MA Lab 3 Technical Report for the inexpensive cooling system. Cooling is one of the most important considerations in building houses in tropical places, according to Al Obaidin, Ismail, and Rahman 2014. Al Obaidin et al. 2014 exposed that there is an unfavorable climate with high levels of solar radiation, high temperatures, high relative humidity, and long periods of sunshine throughout the year in the tropical region. Building cooling loads are largely influenced by solar radiation, according to Maliki 2011, wherein Talib 2014 exposed that the roof is one of the main solar heat gain points in a building, accounted for about 70% of total heat gain, according to Vijay Kumar et al. 2007, as cited in Al Obaidin et al. 2014. Experience has shown that the acceptable comfort conditions for humans vary from person to person. Then, to most of us, temperature within 72 to 78 degrees Fahrenheit, which is equivalent to 22.22 to 25.56 degrees Celsius, and 50% relative humidity are satisfactory. So this is in accordance to the ABC of ERCON. So the use of air conditioning system has been a trend nowadays to give comfort to people. However, the upfront cost of installing an air conditioner, the ongoing cost of power, and the use of chlorine-based refrigerants, which are linked to ozone depletion and global warming of traditional air conditioners, are some factors that discourage some people to use it. Moreover, in the rural areas, the design of the building as well as the materials being used in construction are not suitable for the installation of air conditioning units. The use of bamboo walls, or what we call amakan, are more prevalent there. Thus, the application of natural or passive cooling strategies such as the shading vegetation is another approach to keep a cool dwelling without using air conditioning. So the objectives. This paper aims to design an inexpensive cooling system suitable for use in the rural houses. So specific objectives. Number 1, to measure the dry bulb temperature and humidity inside the house for different time of the day using an Arduino-based temperature and humidity sensor, the DHT11 with Arduino and LCD interface with I2C. Number 2, to get the psychrometric properties of air using the data gathered in objective number 1. Number 3, to propose a design of an inexpensive cooling system that is suitable to use in the house. So for the methodology, this is the process flow chart. So the process flow chart provides the workflow of all the tasks and procedures involved during the process. So this involves measurement of the house or room's temperature and humidity, then getting the atmospheric air psychrometric properties, then analyzing the recent design of the house or room, then evaluating the atmospheric air psychrometric properties and the design of the house or room, then propose a design on an expensive cooling system suitable to use in the house or room. So this is the experimental setup. The testing of atmospheric air's temperature and relative humidity was conducted inside the house of the researcher in Porok City, Sitio Chinese Republic, Barangay Lapacan Sur, Inabanga, Bohol, Philippines. The experimental setup, the DHT11 sensor with Arduino and LCD. This LCD is interfaced with I2C. So these are the photos of the house. The test was conducted inside the researcher's house. The structure was made of amakan walls, GI sheet roofs, and cemented floors. The surroundings have a little vegetation. Most are ornamental plants like the San Francisco. Parameters to measure. So the dry bulb temperature. When people refer to the temperature of the air, they are commonly referring to its dry bulb temperature. So we measure it in testing the atmospheric air temperature inside the house. Then number 2, the relative humidity. It is a measure of how much moisture is present compared to how much moisture the air could hold at that temperature. It is expressed in percent. So both the dry bulb temperature and the relative humidity, we get it from the testing. Then number 3, wet bulb temperature is a temperature associated with the moisture content of the air. Then number 4, absolute humidity. It is the vapor content of air given in grams or pound of water vapor per pound of dry air. Number 5, dew point. It indicates the temperature at which water will begin to condense out of moist air. Then specific enthalpy. Enthalpy is the measure of heat energy in the air due to sensible heat or latent heat. It is useful in air heating and cooling applications. Then specific volume. It is the volume that a certain weight of air occupies at a specific set of conditions. So the more the moisture vapor present in the air, the greater shall be the specific volume. So the parameters wet bulb temperature, absolute humidity, dew point, specific enthalpy, and specific volume are determined using the website www.sugartech.co.za using the obtained dry bulb temperature and relative humidity. So we just plug in the values of dry bulb temperature and relative humidity, then we can get the values of the other parameters. Table 1 presents the psychrometric properties of air for good thermal comfort. So for the dry bulb temperature ranging from 22.22 degrees Celsius to 25.56 degrees Celsius and relative humidity of 50%. So these are the values of the wet bulb temperature, absolute humidity or humidity ratio, dew point, specific enthalpy, and specific volume. For the results and discussions, Table 2 shows the dry bulb temperature and relative humidity inside the house for different time of the day, which is measured using a DHT11 sensor with Arduino and LCD interfaced with I2C. The table shows that at 6 a.m. morning, the temperature is the lowest, but the relative humidity is the highest. Meanwhile, at 3 p.m., the temperature is the highest, yet the relative humidity is the lowest. For the psychrometric properties of the air, Table 3 presents the psychrometric properties of the atmospheric air based from the obtained dry bulb temperature and relative humidity from the test. So as the results obtained, the psychrometric properties of the atmospheric air were compared to the psychrometric properties of air for good thermal comfort in Table 1. It is revealed that all the properties of air were higher, indicating that the temperature inside the house is beyond from the good thermal comfort. Thus, the house or room needed some improvements in terms of its cooling system. For the proposed design of an inexpensive cooling system, based on the photos of the house shown in the figure, and the results obtained in Table 3, the following things can be done to promote natural cooling inside the house. Number 1, use of NIPA roof as substitute to galvanized iron sheet. So building cooling loads are largely influenced by solar radiation, according to Maliki 2011. Talib 2014 exposed that based on studies, the roof is one of the main solar heat gain points in a building. Vijay Kumar et al. 2007, as cited in Al Obaidin et al. 2014, also revealed that the roofing system accounts for 70% of total heat gain. Roofs can be shaded by concrete, sheet metal, plants, canvas, earthen pots, and other materials, according to Maliki 2011. The use of NIPA has been done before in the structure, and it effectively promoted the natural cooling inside the house. Possibly, it is one of the methods of passive cooling that the owners can adopt. Number 2, planting trees and shrubs around the house such as guava, kikayo, jackfruit, dwarf coconut, lansones, and rambutan, among others. Kamal 2010 revealed that trees can be utilized to provide shade for roofs, walls, and windows. Trees can reduce surrounding air temperatures by up to 5 degrees Celsius by shading and evapotranspiration, the process by which a plant actively releases water vapor. Plant trees and shrubs in such a way that breezes are directed, according to Energy Efficiency and Renewable Energy 1994. For the number 3, using of sunshade nets to cover the roof or the windows from the sun's heat. According to Energy Efficiency and Renewable Energy 1994, shading devices absorb or reflect solar heat by blocking the sun's rays. By shading the home, indoor temperatures can be reduced by as much as 20 degrees Fahrenheit, which is equivalent to 11 degrees Celsius. External sun shadings is said to reduce both the cooling load and the annual cooling requirement by a factor of 2, according to one study by Maliki 2011. Number 4, employing of electric fans or ceiling fans. When used to improve performance, passive cooling solutions do not eliminate the need for a fan or a pump. According to Giovanni 1994 as cited in Al-Ubaidin et al. 2014, ceiling fans help to keep you cool. Their effect is similar to a 4 degrees Fahrenheit or 2 degrees Celsius decrease in air temperature, according to Energy Efficiency and Renewable Energy 1994. As a result, it can be concluded that having a fan is also important because fans are less expensive and easier to maintain than air conditioners, as said by Newzibi and Leo 2021.